among 5,383 cases of heart pacemaker malfunctions, 410 were found to be caused by firmware, which is software programmed into the device. If the firmware is tested in 3 different pacemakers, randomly selected from this batch of 5,383, and the entire batch is accepted if there are no failures, what is the probability that the firmware in the entire batch will be accepted? Is this procedure likely to result in the entire batch being accepted? Well, to find this probability, the rule of complementary events and the multiplication rule will be needed. Now, the rule of complementary events states that if A is an event and the complement of A is the event that A does not occur, then we would say the probability of A plus the probability of the complement is equal to 1, or we can say the probability of the complement of A is equal to 1 minus the probability of event A. Now, for this exercise, we're going to let A be the event that a pacemaker fails, and the complement of A will be the event that a pacemaker does not fail. So we're going to calculate the probability that an individual randomly selected pacemaker fails, rounding to 6 decimal places. So we want to go back up and say, okay, well, 410 were found to be caused by firmware out of the total 5,383 cases. So the probability of the event that a pacemaker fails is 410 out of 5,383, which gives it its decimal, rounded to 6 decimal places, is 0.076166. Now, to find the probability of the complement of A, which is the pacemaker does not fail, we're going to use the following formula. The probability of the complement there is going to equal 1 minus the probability of event A. So we're going to take 1 minus 0.076166, and then we get the value of 0.923834. Now we're going to use the formal multiplication rule. So the probability of A and B is equal to the probability of A times the probability of B, provided that A has already occurred. Now, because the number of pacemakers selected without replacement is less than 5% of the batch of 5,383 pacemakers, the 5% guideline for cumbersome calculations says that the selections can be treated as independent. Thus, since the probability of each pacemaker passing is the same, the probability that none of the 3 pacemakers fail can be found by multiplying the probability of the complement of A by itself 3 times and then rounding it to 3 decimal places. So, the probability that all 3 pass is equal to the probability of the first passes and the second passes and the third passes. So that means we're going to take the probability of the first passes times the probability of the second passes times the probability of the third passes. Well, the value that it passes is 0.923834 multiplied by the same number and then multiplied by the same number 3 times, which is the same thing as saying this number raised to the 3rd power. So when we raise it to the 3rd power, we get 0.788469390, and then rounding it to 3 decimal places gives us 0.788. Therefore, the probability that none of the pacemakers fail and the batch is accepted is 0.788. Now, to determine if this procedure is likely to result in the entire batch being accepted, recall that a probability of 1 means that the event is certain. A probability above 0.5 but less than 1 means the event is likely, and the probability of below 0.5 but above 0 means the event is unlikely. So the probability of 0.788 means that this event is likely, and therefore it is likely that the entire batch will be accepted.